And unit vectors of the vectors of A equal to the vectors of A itself divided by the distance or absolute values of the vectors of A. So as you see in the screen here now, the magnitude of A, where I, J, and K, divided by the distance of the vectors of A itself. And direction cosine of vector. So from the origin point of here, O or 0, 0, 0, so direction of cosine of vector. Okay, this is the we call an angle from the x-axis to the vectors of O to A, and beta represent the angle between the we call y-axis with the vectors of OA, and here gamma represent the angle between the z-axis with the line of O to A. Okay. So vectors of A, OA, as you see in screen here now, AI plus A2J plus A3K. If A makes an angle of alpha, beta, and gamma with a positive direction of X, Y, and Z axis respectively, then okay, so cos alpha equal to the magnitude of A1, which is I, divided by the distance or absolute values of the vectors of A, cos beta and cos gamma, as you see three here now. So direction angles of vector of A, alpha equal to cos of A, we call magnitude of I, A1 divided by the modulus of A, also with B, and also and here for gamma. Okay. And note that cos square alpha, okay, cos square alpha here plus cos square beta and cos square gamma equal to 1. Okay, there is a given example here. If A equal to the vectors of A equal to negative 4i plus 2j plus k, and vectors of B given then negative 3i plus j plus k, so find the absolute values of A, the vectors of A, and the unit vector of A. Okay, so let's continue. Okay, I rewrite or write again the both of vectors of A and B, when vectors of A equal to negative 4i plus 2j plus k, and the vectors of B equal to 3i minus 3j plus k. Okay, so then the first question given, then find the this one here, which means that we are going to come up with this formula of negative 4 square plus 2 square plus 1. Sorry. Okay, 1 square. Okay, so come up here now. Square of 4 equal negative 4 square equal to 16 plus 2 square equal to 4 plus 1 square equal to 1. 16 plus 4 is 20 plus 1, then you come out with square root of 21. Okay, so then the unit vector of A, okay, equal to the vectors of A divided by absolute values or distance of the vectors of A, which is negative 4i plus 2j plus with k divided by square root of 21. Okay, so then we list down here one by one. It is negative 4 divided by square root of 21i plus 2 divided by square root of 21j plus with 1 over square root of 21k. Okay. Then for question B, please refer to the we call the lecture notes then. The direction cosine and direction angle of vector of A. So then direction cosine of vectors of A, which is cos alpha equal to okay, direction cosine for each of these cos alpha equal to negative 4 divided by square root of 21. Okay, cos beta equal to 2 divided by square root of 21, and cos gamma equal to 1 divided by square root of 21. Okay, so now the direction angle of the vector of A okay, so which is negative 4i plus 2j plus k is given then. Okay, actually that we get it all the answers from here. Okay, look at the first one here now. From cos alpha equal to negative 4 divided by square root of 21, then alpha equal to arc cos of negative 4 divided by square root of 21. Okay, so if I manage to find the answers using the calculator here, press the button of shift and cos and it gives you a cos. Okay, and then set up recall the calculation. Then it is negative 4 okay, divided by square root of 21. Okay, as you see string here now, then press the enter button here. Okay, so it gave me 150.8 degree. Okay, so now this is for alpha. So what about the rest of them? Okay, I'm gonna clear this class. Never mind. I think that I'm gonna solve all this in your examination. Please write it properly, and the answers recall in one page. And then, if the page is full, please go to another page. For these lectures, I just write down all here, not to recall. Wasting so much time here. Okay, now. Look at this one here, cos beta equal to 2 over square root of 21. So then, beta equal to arc cos of 2 divided by square root of 21. Okay, so press the button arc cos here. Press the button of shift and cos. It gives you a cos. Okay, and then setting up we call the formula inside, which is according to that one is 2 divided by square root of 21. Okay, as you see the screen here now. Okay, and press the button equal. What you see in the screen here now? It gives us 64.1. Okay, so you may repeat the process to find that variable, the value angle of gamma here, and I straightly give you the value of this gamma equal to 77.4 degree. Okay, so we get three values of angle, direction angle, or vectors of alpha, vectors of A here. Okay. Okay. Oh, okay. We reach the conclusion, which I think that you almost at the end of the at the end of the lecture here now. Okay, so I'm not gonna look at this formula before. Wait a minute, which I think that I'm only answering question of A and B only, right? A, B, and wait a minute. I only answered the question of A and this one here, and also question of B. So I forgot to continue with the question of C. Okay, never mind. Again, rewrite the vectors of A equal to negative 4i plus 2j plus k, and the vectors of B. Okay, sorry, it's the vectors of B then here. Vectors of B equal to 3i minus 3j plus k. So question C is find the vectors of A plus with B. So look at this one here now. Magnitude of I with negative 4 plus 3i plus with magnitude of j, which is 2 plus negative 3j, sorry, plus with k, 1k and 1k. K 1 plus 1 for k here. So negative 4 plus 3 equal to negative I. 2 plus negative 3. So 2 minus 3 equal to negative 1. J, and 1 plus 1 equal to 2k. And the next question is 2a minus 3b. So 2 times vectors of A, negative 4i plus 2j plus k, minus 3 times the vectors of B, 3i minus 3j plus k. Okay, so multiply k, the constant of k, with every single magnitude here. 2 times negative 4, negative 8i plus 4j plus 2k, and then minus 3i. 3 times 3 equal to 9i, negative 3, negative positive 9j minus 3k. So negative 8 minus 9, negative 17i. 4 plus 9 equal to 13j, and 2 minus 3 equal to negative k. Okay, there you go. Okay, so we go the sign of the vectors there.